get started. Does that sound all right? So maybe some more people will come in and join us, but I really appreciate that you guys are here already. And I hope that the next hour will be informative and helpful. My name is Travis Spencer. I'm the CEO of Curity. And I'm going to be talking to you about OAuth and OpenID Connect for, like I said, the next 60 minutes. And we're going to try to cover as much that we can in that time. So I'm going to go pretty fast through the intro stuff, but I did want to say that Curity is a Swedish company, and we're a software provider of OAuth and OpenID Connect. So these things are very near and dear to our heart that I'll be discussing about today. We've been working in this space for quite some time. Curity Identity Server is run by many organizations around the world, a lot of them here in Europe. And I, for myself, have been working in this space exclusively for at least the last decade. I'm American, but I live in Sweden. And I've worked in various sectors like automotive, banking. I've worked for government agencies, different sorts. And so I've seen these problems growing and evolving from the SOA time and the WS star time into the more RESTful era that we're in today. And so that's really where OAuth and OpenID Connect fit. So that's a little bit about Curity, a little bit about myself. I also did want to say that Curity is a sponsor of this event, but we're also running Nordic APIs, which is a community for people who are learning about APIs and sharing information about APIs. We have a number of events like this one all over the world. Our biggest one will be in just a few weeks in Stockholm, the Platform Summit, we call it. And that will be in Stockholm. And we also do the Austin API Summit, which will be next year. And that will be in Texas. We also, in the meantime, have a lot of different blog posts, a lot of different ebooks, a lot of different videos from past events that are all on our YouTube channel, so you can go there. So I'm only going to talk about API security, but Nordic APIs is covering the whole gamut. So you can take that away as a helpful resource, and I'll also give you some links at the end. Some of them are to Nordic APIs. But now I want to jump right into OAuth, and I want to start with some basics just to sort of set the ground level, and then we'll get into some more advanced topics as we delve in and go deeper. So OAuth 2 is a sort of protocol of protocols. It's called a framework, and what this means is that standard can be used as the basis for other standards. And the way that it does that is by profiling them, or sort of narrowing the scope of them, changing some of the musts into, or the cans or mays into musts. And examples of standards that build on top of OAuth are things like OpenID Connect, which I'm going to look at a lot, but it can be other things like HART or UMA, and there are others. So this sort of a framework that can be used. As a consequence, there's a lot of leeway in there. So just saying we are doing OAuth is probably not always accurate. And so we'll look in more details of what that means. But really the idea with OAuth is it was meant to solve a few things. One of them is to provide delegated access so that you could say, like, this application can do things on my behalf. And to do so in a way that you don't have to give that application your username and password or your credential. So it reduces the danger of sharing a secret with an application that you later may not trust as much. And so it does this in a way that can be revoked, so that you don't break every other application that you're not revoking access for. So if you changed your password, you would be revoking all of them, and all of them would be broken as a consequence of just wanting to revoke access to one. So OAuth is really designed to solve that, but done in a way that it's a framework so that other problems and other use cases can be solved. And we'll look at some of those. Before we do, though, it's important to know about the different actors that are involved in OAuth. The first one being the resource owner. The resource owner is a sort of academic word for the user. So the one who is owning the resource, it doesn't always necessarily need to be the user. It could be an organization per se, but usually it is a user. And then there's the client, and this is the application. And the application is the one that wants to do things on behalf of the user. It can be a web application, it could be a mobile application. And then there's the authorization server, and this is the actual entity that is issuing tokens. And the authorization server is sometimes called the identity provider, sometimes called the OpenID Connect provider when we talk about OpenID, but it can also be thought of more in a general case of a security token service. And then finally, there's the resource server, and the resource server is the one serving the resource. So this is sort of like your API. And the general idea with OAuth is that we have some sort of application, and it wants to get tokens and it wants to use tokens. And it uses tokens by calling APIs. To the end user, the way this looks is you'll request access, the user will log in, and the user will consent or authorize that application to do things on its behalf. So the requesting access could look like a button saying sign up or start or register, or it could happen automatically. You come to the web application and you don't have a session and you're just redirected over. So requesting access can manifest itself in different ways. Login also can manifest itself in very different ways. You could log in with the username and password. You could log in with an EID of some kind. You could log in with a Kerberos ticket that you don't even see. How you authenticate is completely out of scope for OAuth. Then finally, there's consent. And this could look very differently in different cases. It could be asking you for different amounts of consent. It could be progressive, so more and more is needed to be given. And it could also be the case that you've already consented by signing up to download the application. Could be in the terms of service of that application. It could also be in your employment agreement or your customer agreement. So you might not see an interactive dialogue or part of that. But usually this is the way it works. Behind the scenes, what happens is the application, when we click sign up or log in or whatever, will redirect to the OAuth server. And that's a really simple HTTP-based redirect that is meant to make the application simple to start the flow. And this redirect, inside of that, we'll get into that, will have some different parameters that will tell the OAuth server which sort of message exchange or flow you want to do. And this one that I'm talking about in the top left is the code flow. So in this flow, the next thing that will happen is that authentication event will take place. Who are you? So the user will authenticate themselves, and then the OAuth server will perhaps show consent, but perhaps not. And either way, it will send back an authorization code, some sort of credential or token, you could call it, that is signifying to the application that the user has authorized the application to do something, but the application now needs to prove that it is that application. And the way that it does that is it makes a direct call from the client to the OAuth server with a credential that only the application has. So this is a server-to-server flow, whereas the other one was taking effect through the user's agent or browser. So in this request here, the client can authenticate. And typically that's done using basic authentication, could also be done using mutual TLS or both, different ways to do it. But by hook or by crook, the application has to inform the OAuth server who it is and present that authorization code so that the OAuth server knows that the user really did authorize this application. So then the response to this, in this back channel communication, is an access token and a refresh token. And we'll talk about what those are. But then with the access token, what it can do is now the client can start to make API calls. And what's really cool about this is that the backend API can see from this token who the issuer of the token is. It can see who the application is, because the application had to authenticate, and it can see who the user is, and the user had to authenticate. So all three of those entities are authenticated by the time a token is presented to the backend API. And this is novel. This is unique to OAuth, and this is something that we didn't have in the WS Star days unless we did very complicated WS Trust flows. Another sort of novelty around OAuth is something called scope, scope of access. It's often called scopes, plural, but really what they are is sort of like permissions or rights, entitlements even, that an application could have been delegated on behalf of an end user. So they're sort of trying to say the extent of authorization that the user has delegated. They're sometimes listed on a consent user interface like this. You should never do that. in this sort of fashion, but a lot of times the application will present to the user saying, I would like to do these sort of things on your behalf. There's no standard scopes in OAuth. There are in OpenID Connect, and we'll look at some of those. This allows you to do a lot of things. Allows you to do different security models and to use those in your security model. I mentioned that there are different kinds of tokens. So we have access tokens, an access token, and we have refresh tokens. And to help you understand what those are, I like to think of them as like an access token is like a session. Once I have that session with a website, I don't have to keep logging in over and over again. I can just keep using the session I already have. But to get a session, I have a password, some sort of more long-lived credential. And if I present that password, I can get sort of bootstrapped or jump-started to get a session. And so the refresh token is a way of doing that. So if your access token has expired or you don't have one, if the client application has that refresh token, it can say to the OAuth server, hello, I'd like a new access token, and it will give it one. And so this is a way of prolonging a session or getting a new session, so to say. So the intended audience of the access token is the API, and the intended audience of the refresh token is the OAuth server. So you send the OAuth server the refresh token, and you get back fresh tokens. Okay? There are different profiles of tokens. The two you need to be aware of are bearer tokens and holder of key tokens. So the word bearer token, I find a little, confusing. So one thing I like to do to help myself understand this, and hopefully will help you too, is that it's called bearer because it's like a bearer bond. You know, you always hear about in those movies. And so anyone who bears the bond can spend the money associated with that bond. I don't know if that's exactly how it is, but I think that's how it is. So a bearer token is one who bears the token can use the token. So if I find a token, I can use a token. If I find a bearer bond, I can spend a bearer bond. But there are other kinds of instruments, other kinds of tokens that it's not like that. You can't just take one and use it because you hold it. And so a holder of key token is one where it's tied to the one to whom that token was issued. So an analogy here is credit cards. So even if I find 100 euros on the street, I can spend that because that's a bearer note. I can't do that with a credit card. So if I'm finding your credit card out there, I can't go and spend 100 euros on that because, first of all, I don't know the PIN, but also the one who I'm trying to use that credit card with should ask me for some sort of identification if I don't have that PIN. So it's tied. The credit card is tied to the one to whom it was issued in the same way that tokens are tied to the one to whom they were issued. And the way that tying is happening is that the one who is trying to use the token has to prove that it is in possession of a key. And so a lot of times holder of key will also be referred to as proof of possession tokens or POP tokens. Okay? Are all these analogies helping? I hope so, because it can be a pretty confusing space. So I don't mean to overwhelm you. If you do have questions, you can always just ask and we'll try to get to them. We have a lot of time, so we don't need to save it to the end. Yes? Yes. Yeah. Yeah. Even further. You've been sorry. Yeah.
You can use the token to identify the user and everything.
Yeah.
Is this true already in OAuth 2, or is it something which is specific for OpenID Connect?
This is true even in OAuth 2. Exactly, which actually takes me to this slide, is that OAuth 2 doesn't say anything about the kind of token. So, exactly, I'll definitely get to that. I'll sort of answer your question and maybe tie it back into this because I have a few slides on that. Is that okay? Okay, super. So OAuth doesn't say what kind of types of tokens can be used. You can do anything. A string, like our colleague has said, is perfectly acceptable. But we can have more structured tokens like WS security tokens or SAML tokens. We can also do CBOR web tokens. We can do JSON web tokens, but we could invent something in 3 years from now and start to use those. I mean, CBOR wasn't in this slide deck when I was talking about this stuff 3 years ago, but it is nowadays because it exists. And OAuth didn't need to be rewritten, didn't need to be updated, anything like that. And this was actually thought to be one of the real deficiencies of OAuth, because in the WSStar days, it was all profiled for every single type of token. But then that sort of puts it all in a box, and if your use case doesn't fit in that box, you're sort of stuck. So this provides a lot more flexibility. And one of those types of tokens is JSON web tokens. And these are pronounced JOT, like to write something quickly. And these are meant to be lightweight tokens that can be passed around in HTTP headers or query strings. They're encoded as JSON, which is nice because it's a very low-tech barrier. It's a lot harder to write something like an XML parser than a JSON parser, and it's also not a secure normalization. And XML is much more dangerous than normalization in JSON. So it's a sort of more secure baseline. They're very compact. You can attach them not only in the headers and the query strings, but also in HTTP payloads. You can sign them, you can encrypt them, you can do none of those if you don't need that. But it's not the only kind of token, like I talked about. You could have other kinds like CBOR and whatnot. And then building onto the question there, we can pass tokens in different ways. So we have all these different types of tokens, and we can pass them in different ways. But there are 2 ways. We can pass them by value, we can pass them by reference. And those terms I take from the programming sense of calling functions or message passing. I can pass something by value by putting all of those values onto the stack, and the receiver of that message will have those values. Or what I can do is I can place a pointer on the stack, and the receiver of that message has to dereference that to actually find the values. And it's the same way with tokens. So I can pass all of the identity data of the token by value by putting it into a self-contained token like a JSON web token or a SAML token. But I could also pass it by reference by having just a pointer. And this could be a random opaque string that no one understands except for the OAuth server. And so it has to dereference it in order to get access to that identity information. So to answer your question of how could you actually identify the issuer, well, it depends. If it's by value, then the issuer information is going to be in there, and you're going to be able to cryptographically prove it by verifying some sort of signature or by decrypting it and knowing that, no, not by decrypting it, by checking a signature. Or if it's by reference, you're going to have to call out to the OAuth server and say, hello, did you make this or not? So in either of those cases, with any of those types of tokens, you can see the issuer, and then you could also see if you trust it, and if it asserts that a certain client was used, then you've now authenticated the client. And if it has authenticated the user, then it would assert that too. But it's coming down to the receiver of this token trusting the issuer of that token to have done the job of authenticating the client and the user. Good? Super. Any more questions while I drink a sip of water? All right, great. I'd like to talk a little bit about improper usages of OAuth. A lot of times I go around to these sort of events and meet with people, and they say, we're doing OAuth, and so our APIs are secure. And that's a good start, for sure. I think it's definitely something you should be looking at before doing something yourself, but you need to make sure that you're using it in the right ways. And a lot of times I hear people say we're doing OAuth for authentication, and it's simply not possible to do that. OAuth doesn't say anything about how to authenticate a user. It says the user must be authenticated in certain cases, but how you do that, it doesn't say. So you can't really be using OAuth for authentication. I'll sometimes, very rarely, but sometimes do hear that it's being used for federation, and it's not a federation protocol. So it's not talking to other entities and other security domains. So federation is simply not possible with this protocol. And it's not really for authorization. So OAuth, and it's not for authentication or authorization. What the hell is it for? It's for delegation. It's for delegating your rights to something else. It's for saying, I have the ability or the rights or the entitlements to do something, and I want someone else or something else to do them on my behalf. And that's not necessarily authorization. So the thing that is actually serving that resource, the resource server, it is the one that decides if you should be able to access that resource, not the end user. And this tends to get conflated or mixed up because a lot of authorization policies are very simple. If the end user has allowed it, the resource server will serve it. But it's not always that simple. We could have very complicated authorization policies and authorization rules where it isn't the case, where just because a user says this app or website or whatever can do something for me doesn't mean that it should. And an analogy I like to use is of a business owner and an assistant and a banker. So the business owner might hire an assistant and say to the assistant, you can do stuff on behalf of the business, like taking money out of the company's account. So in this case, the assistant would be the app, the client, and the business owner would be the resource owner, and the banker would be the API. So the assistant now has been delegated rights to take money out of the company account, but then when the assistant goes down to the banker might say, well, that's great that the owner has said you can do these things with the company account, but I'm sorry, access denied. Neither you nor the owner filled out the proper paperwork, so I can't authorize you to take money out. You guys could come down here and fill out the right forms, and then I'll authorize that sort of withdrawal, but not before. So even though the business owner is delegating rights, authorization isn't allowed. So OAuth should really be called ODelegation, but that would be kind of cheesy, especially now. I said at the beginning that OAuth is profiled by different standards, and the most popular one of those being OpenID Connect. If you Google around for it, or even I think in the spec itself, it says it adds an identity layer on top of OAuth. So what does that mean? It means that the poor application, the client, kind of got left out of the party. We have an access token. Think of the case where it's just an opaque string. We have no identity information whatsoever, and the application is uninvited. It can't see how the user logged in, it can't see who the user is, nothing like that. And so what's the first thing it needs to do, perhaps, is like, welcome, Travis, to my app. Great that you're back. You know, it can't do any sort of personalization or customization like that. It doesn't know anything about my accounts or something. So we need an identity layer, so to say, by allowing the front-end applications, the presentation, to know who the user is, how the user is logged in. And OpenID Connect provides us with that in two primary ways. First, with something called an ID token. So when we did that flow before, we should give a token that the application can see who the user is and how they logged in and when they logged in. And the other thing is, instead of having to make an API that you have to call and get identity data, it should be a standard API. And that's the user info endpoint that it's called in this profile. It's really made for mobile. It's not backward compatible with other versions of OpenID Connect, but it is based on OAuth 2. So most of the time you'll build these two together into your server, or they'll both be included in the product you're using. But this bullet here, client and API to receive tokens. This is the novelty of OpenID. So let's look at how this works. We did the code flow once, but now we'll do it in more of an interactive manner. But it's the same basic flow. One of the differences, the primary difference though, is at the kickstart, at the beginning. The client application, which I'm sorry to say gets a different name in this standard, called the relying party. So this application will redirect over to the OAuth server, and it will include a scope equals OpenID. And when the OAuth server gets that and sees, okay, scope equals OpenID Connect, it sort of clicks itself into OpenID Connect mode. And if you have an OpenID Connect provider that's not an OAuth server without that scope, it might say like bad request. But with that scope, it will return that authorization code that we talked about before. Here with access code, bad habit of mine. But it will get that authorization code, and the client will authenticate itself to the token endpoint, to the OpenID Connect provider. And this is where it changes now. Instead of just giving a token to use to call APIs, it invites the app to the party and says, okay, here's an ID token. This includes Travis, shoe size 44, hair color blonde, bald true, all this stuff into the ID token, so the app already knows and doesn't need to turn around and make an API call to say who logged in. If it wanted to, though, it could check that the token was for it and then turn around and use the access token to call over to the user info endpoint and get back user information. And what's interesting about this user information is what is returned in that API call is only what the user has delegated or allowed the application to see. I don't allow this application to see my phone number. I don't allow it to see my email, but I'll let it see my time zone that I'm in or something like that. Make sense? So it sort of constrains what's being released. Questions while I take a sip? Good. So the ID token is for the client, like I said a few times. So access token is for the API, refresh token is for the OAuth server, ID token is for the client, one token per party. And so this way we can sort of scope what ends up being in there. So the ID token will provide things like I mentioned, but it could also include stuff like when the token was issued, when it expires, client that was used to log in, so it can check that it's appropriate. User info endpoint. So this is a really interesting endpoint. Usually it's just user info, but it's sort of like a shotgun where you can also issue a bunch of tokens. You can then from that client start to call different APIs with different tokens that this user has allowed for. And it's authenticated using the token that was provided in the code flow response. And it depends, like I said, on the scopes that the user authorized. Okay. Should we look at that? So here I have a client that I've written. This is a Python client, one of my favorite programming languages, but not the easiest to do advanced security stuff in, I must say. I find it even sometimes hard to do simple things like hashing in Python, but the language itself is great. So I have written this Python application, but to keep it simple, it delegates, so to say, or outsources all of this advanced security to the identity server or to the OAuth server. So what I do here is remember I said the first thing the user sees is a sign up, a login, a get started button. So I click on this and now I'm redirected to my OAuth server. And my OAuth server, not surprisingly, is the one that we provide, but this is what it's doing now is saying how do you want to log in? Because I've configured mine to allow for different login methods. And so I'll click this button, select username, password, and my password manager has remembered my username, so it's even pre-filled, which is nice. But now I log in, and now the OAuth server responds back to the client and says, okay, here is an access token, like the ones we talked about. So here I have an access token, and I have a refresh token in case I want to extend the life of this session. And in the upfront request, you couldn't see it because it was in my browser flow, but if we want to inspect it, we can. One of the parameters I included was scope equals OpenID. So the third token I get back is this ID token. And this ID token is split into 3 parts. So the first part is a header, second part is the payload, third part is a signature. And this part here in this big box is the payload of that ID token. So the application can inspect that and see this is how the user logged in. You all saw me do that with an HTML form that is configured to be called HTML SQL for whatever reason. And then the authorizing party, the one who is authorized to do these things on behalf of the user, is the Python client. I can see that this is definitely for that application, and I can also see who the user was that logged in. So that's the OpenID Connect code flow. Questions? Making sense? All right. We'll go to some deeper, more advanced stuff. We're making good time here, so that's great. But you can always ask your questions. So let's talk about metadata and dynamic registration. Sometimes environments are more fluid, are more dynamic. They need to, clients need to be registered in a more ad hoc way. Some good examples of when you would do this is an iOS application or an Android application. So you build an application in the factory, so to say, in your laptop, and then you deploy that up into the App Store, and then I download it, and then I start using your app. Wouldn't it be great if my instance of that application had a different identifier and a different secret than your installation of that, so that you could see like who is actually using which app, and you can revoke yours instead of mine or vice versa without affecting the other users. It's a way of making mobile development more secure, so that every installation ends up with a different secret, different client ID. Another example of when you might have such a network is I fly from here to Taiwan, and I land there and I put in my phone number, and it figures out, okay, with a +46, I'll contact back to Sweden, and the mobile network operator that you belong to is Telia, and get yourself logged in, which now means that someone over in Taiwan needs to dynamically register to become a client of the Swedish OAuth server. So there was maybe no relationship before. So we could create very dynamic ad hoc networks, identity networks, so to say. There's other cases for this, but that's two to sort of give you an idea of where this fits in the big picture. There are different variants, like standard-wise, of metadata. OpenID Connect defines its own, and it was done first of all. And then the OAuth crew said, yep, that's really helpful. Let's have a version of that as well, and let's write the standard in a way that OpenID Connect conforms to that, but let's make it more general, because there are other use cases. And to find the metadata document, maybe the OAuth says it should just be in the documentation, or you should follow the OpenID spec, or do something else. So it gives some leeway. But with OpenID Connect, to actually find the location, you can use WebFinger. And to find the WebFinger location is defined to always be a well-known /WebFinger. And from there, it will tell me where the URI is. But in OpenID Connect, it's always at .wellknown OpenID configuration. And when I call that endpoint, I get back a bunch of JSON describing the OpenID Connect server. So let's look at that. This is like a puzzle, so you have to stay on your toes here, even though this is starting to get a little boring, because what I just showed you here is going to connect back, but it's going to take about 10 minutes. So stick with me. So metadata, here it is. So I get back a bunch of JSON, as I mentioned in the PowerPoint. And this is describing all of the sort of tuning of the server. Let me make it a little bigger for you. And this is saying like what scopes are supported. These are a bunch of OpenID Connect ones together with some others. And then this is my issuer. This looks like a strange issuer, but that's my URI. That says like when a token comes from this issuer, it will have that string. And the issuer is a big part of the puzzle here. So I have the issuer, and I also have one called JWKS URI. And if I click this, I open up another bit of JSON. And this is defined by JSON web keys. And this is describing all of the keys that the OpenID Connect server has, the OAuth server has. And these keys are in JSON. And in this case, I only have one key, which is an RSA key. And that RSA key is a certain length, 256. And that can be represented by a modulo and an exponent, the modulo being the N, and the exponent being the E. And now anyone who gets that can compute a key with that. This isn't a certificate, so this isn't signed by some sort of third party. So that's why you don't see anything more than that. Actually, I lie. It is a certificate, and this is the SHA-1 fingerprint of the certificate. But if you don't know or have that certificate, you can at least still compute the RSA public key. Okay, metadata, dynamic networks. One of the pieces of the metadata is the issuer, the other piece is the JWKS URI. Okay, questions? Super. Let's talk about something called proof key for code exchange. So I mentioned holder of key. I mentioned that sometimes you could get access to a token and use that because it's a bearer token. An example of that is the authorization code that could be presented on the back channel. So with the Python application, I can sleep pretty well at night. believing that authorization code is not going to be intercepted or taken away by some other application. But in other environments where it's not a web server, perhaps, but a mobile application, I wouldn't be able to sleep as well at night, because there's sort of three parts that have to be assumed in order for that authorization code not to be intercepted. First is that the callback where I got redirected from the OAuth server back to the Python app is secure, and that it's not being eavesdropped. And in the Python case, I was running on TLS, so that's scrambled and I can't get access to that authorization code. The other is that the token endpoint needs to be authenticated, and there was nothing between my Python app and my OAuth server, but in some environments that's not the case. There could be some sort of man in the middle who is gaining access to that authorization code. And that last is that the callback is unique per client. So there's nothing else on my local host at port, I think it was 8443/callback. There's only one service listening there. But in other environments, that is not necessarily the case. And the primary example of that is, as I say here on the last bullet point, mobile applications. So a mobile application, we can't assume that the callback is encrypted because we could be using a custom scheme there, like myGoodApp : / something. And we don't necessarily have encryption on that callback. It's also not necessarily the case that the client can authenticate, because there could be some sort of man in the middle or proxy or debugger attached that could easily intercept the client ID and secret. And thirdly, other applications could register on that mobile device, and therefore the callback wouldn't be unique to that application. Two of them could share the same one, and then it would maybe depend on which one the user selected. So we don't have any of those three cases holding true in mobile applications. So the authorization code could be intercepted. And so what we wanted to do is change that from a bearer token into a holder of key token, proof key for code exchange. So the way that we do that, or the way the attack works, is we have some sort of mobile operating system, and in step one, the authorization request is done in almost the exact same way as with the Python application. And then the user is redirected there in step two to the OpenID Connect server. The OpenID Connect server responds back in step three, and oops, the authorization code is redirected to the malicious application. The malicious application takes the client ID and secret that it's intercepted, and it redeems the authorization code. Since it's a bearer token, so to say, it now gets an authorization access token that allows it to call APIs as the actual legitimate client as the actual user. Okay? So what we want to do is make sure that that's not possible to do. So at the very beginning, what we want to do instead is we want to include the usage of a key. So this is how you make a holder of key. Is a holder of key has to use the key. So the first step, step 0, is create a key and use it. So it will use it by taking some random value, and it will hash that with a key that only it knows. And it will include the hash in step 1, and it will say what hashing algorithm was used. So then it will go to the server with the hash in step 2. Step 3, it will come back as before. Step 4, the application intercepted it, unfortunately, but now it doesn't have the key. It's no longer a holder of key here. This is a proof key or a sender-constrained token, the authorization code is. So when it authenticates with the stolen client ID and secret, it doesn't have the secret key, so the OAuth server says, no, I'm not issuing any tokens to you. So if the legitimate application would have got it, however, which would usually be the case, thankfully, it does have that secret, and so it will send the secret as is. So this is like a one-time usage key, one transaction, you'll throw that key away. But it would send it to the OAuth server, and it would remember, you said it was this hash and this hashing algorithm. I can now take that key and make sure that I come to the same hash. And if I did, then the one who started the flow is the one who ends the flow. Make sense? So let's look at that. Pixie. I just like saying that, Pixie. How do I close this thingy? Oh, you guys can see it. I'll just have to go here, I guess. Do my best. Here we are, network. So let's redo the flow. And if we look at this one, we look at this one, and you can see here this one. No, sorry. This. Here. So we have the code challenge. This is sent, if you look, it's hard for me to see from the stage, but I think that endpoint is called authorize. So that's the first endpoint of the OAuth server that you'll send the request to. And it includes this code challenge. I can make this a little bigger, I think. And it says the code challenge message is S256. That means a SHA-256. So now later on, when I redeem the authorization code that's given to me here, you can even kind of see it in the code equals Zord stuff there. Then I'll have that secret, and my Python application can send it to the token endpoint, and the OAuth server can piece that together. Okay? Questions on that? Good. So now let's see if I can fix this. Yes, I did. And then sorry, gang, this screen is competing with me. Oh, wow. I can't get my cursor past there. It's strange. Still can't. Oh, it's because I've unplugged the power. That doesn't help. There we go. Think of a question. Help me out. I can answer questions and fix audio video. Okay. All right, so Pixie, we saw metadata. So a mobile application, what it will usually do is upon installation, it will call to the OpenID Connect server and say, hey, can I register? And it will get a client ID and a secret unique to that installation. And it will say that I'd like to do the code flow, and I'd like to be able to do Pixie with that. And so then it will do this flow here that we just saw, and it will make sure that those codes aren't intercepted. And then the other thing I want to show you is that when it gets back tokens, it will be able to validate them with those secrets and with that metadata. So we looked at JSON web tokens. We looked at how those are by value tokens. So those include a signature as the third part, and we want to verify those signatures. So mobile applications, when you do this Pixie flow, one of those things you'll get back is an ID token, and you'll want to verify that and make sure that it is the end user. And even if it's a non-mobile app, it's like my Python app, the way that you do the verification is always the same. There's some variants of this if you're not using dynamic registration or as fluid of an environment. But the way that it works is that we would extract the issuer claim from the JOT token, from the payload. So let's look at that. Hopefully this won't mess up the monitor again. Step 1, extract issuer. Here it is. Remember that was that odd looking URL I mentioned? That's my issuer. Take that and append this to it. because we're doing OpenID Connect, we know that it is this string. So let's take that. I think I can even just drag this up here. And then that, but without the quotes and a slash. And now we're back to this place. Okay, so now I can find the metadata from a JSON web token. That's helpful. So even if I've never seen this OAuth server before, I could validate tokens by following this algorithm. So third thing is then from that metadata, extract the JSON web key URI. So we go here, and as you saw before, JSON web key is part of that. The application will go there, and it will find a key set. So this 0th element in the array is a JSON structure that includes the key type, RSA. Everyone knows how to handle RSA. That's easy. I should use the modulo and the exponent to do to be able to do an RSA 256 signature computation. But which key, right? Just because I see a bunch of keys here doesn't mean I'm going to use them. So I want to go back to my header of the job. So remember there were 3 parts: header, body, signature. So the body has the key ID that was used, because I might call out to that JSON web key set URI and find a key that's not there. How do I know which of, or I might find 20 or 50. How do I know which of those I should use? The key ID tells me. So those of you with better memory than me, remember 3807 something. 3807 something. This looks like it. So there's only one of them there. This was an easy case. But if it was a more complicated case and there was many of them, I could at least begin to figure out like which of those was the one that was used by looking at the key ID. Key ID is not required. Like I was saying, there's some variation on this. So I might just know, I might tell you, I might call you on the phone and say, you know, my key ID is 22. But usually it will be like that. So we get that. We get the key ID out of the JOT. And now we need to create a public key from those base atomics. Like if this was an elliptic curve, then it would be like the curve name, things like that, instead of an N and a E. But anyway, I create the public key. And now look at the header of the JSON web token. It also tells me the algorithm that was used. So RS-256. And this one can be used to do RSA-256. Okay, this is looking good. So now I can use that key that I've computed, and I'm going to run it over this JSON structure. And I should get back the same signature that's in the footer of that. And if so, then it at least came from that OAuth server. Whether or not I trust that is another question, but I've at least authenticated the issuer in a pretty ad hoc manner. So again, this header includes a SHA-1 fingerprint of a X509 certificate, so I could also chain this up to a PKI. This could also include the entire certificate chain. So if I wanted, I could include the entire chain here. So there are, like I said, different variants of how you would do this, but this is the vanilla algorithm. Okay, questions on that? I got 12 minutes. I'm going to just keep blazing forward unless someone raises their hand. All right. So I want to jump back a little bit and talk about another kind of application. I've talked about web applications with the Python example, and I've talked about mobile applications. But another kind of application that's very often built is what we call hybrid applications, where part of the application is a more traditional web server application, but maybe the newer parts are built in a HTML and JavaScript environment in a single page application using Angular or React or whatever. And those sort of hybrid applications have a hybrid flow. And the point with the hybrid flow is that each of those two parts wants to have a token. So there is another flow that I won't talk about today called the implicit flow. And the idea with implicit flow, I'll just give you by way of background here, the implicit flow doesn't see any point in authenticating the client, that back channel call, because it can't keep a secret. It's JavaScript in this case. It's HTML. I could view the source. So why have a secret within that source code? everyone can look at it. So rather than sort of making the client authenticate all the time, just don't. And there are security consequences of that, right? Because now we at least know the user and the issuer, but we no longer know the application. But when building hybrid applications, and part of it actually can authenticate because it's in a web server where it can keep the secret, and half of it is in a place where you can view source, wouldn't it be great to know like which of those halves are calling the API so that you can make authorization decisions differently? Hybrid flow allows you to do that. And I mentioned, but I'll mention again, that the idea with OAuth 2 is to make applications easy to build. All the complexity moves to the server. Hence companies like Curity, who all they do is provide servers. Because they're hard, they take a lot of work. But for the client, it's very easy. I just change some query string arguments. I mean, this is like not even CS 101 type complexity. Very simple stuff. I want to do the flow and say to the OAuth server, I'm building now not a mobile app or this app or that app. I'm building a hybrid app, so I want to do the hybrid flow so I can get different tokens into different parts of my app. Instead of just saying response type equals code, which I didn't have time to go into with the Python app, I also say I want an ID token back. And I want to do it implicitly, like without authenticating the client, because there's no point because of the JavaScript client. So the response type here you see on the sort of dark blue circle on the outside left, it will include its client ID as well as the code and ID. And on the fragment, it will get back the code and directly the ID token without the client authenticating. So the fragment, I'm not a JavaScript developer, but it's the hash thing at the end of the location of the window object. So then you can see directly with your JavaScript application the fragment. You have the ID token, and now the JavaScript part knows this is T. Spencer that logged in with an HTML form or whatever. So maybe it could start to customize as it starts to make AJAX requests. And one of the first AJAX requests that it will do is to its backend with the code. And so the backend will receive the code, and that will redeem it on the back channel just like we did before with its ID and its secret, and it will get back a different ID. So I called it I prime instead of on the second flow, the green flow with just I. So they're different ID tokens. So they could actually contain different data. So I might release more information to the web application than the front-end JavaScript application. And I also give it an access token. So in this case, the front-end JavaScript can't call any APIs, which is maybe not what you want. So there's another variant of hybrid flow where you can provide a code and token. And now what happens is on the fragment, I get access token A, and then I can redeem the code on the purple third flow here, and on the back channel then get a new access token, A prime. So now my front-end JavaScript has an access token and my back-end application has an access token, and they're different and could allow for different things to happen when that API is called. And then finally, the third variant of this flow is that we can say we want a token and an ID token for the front end and still give the code for the back end. So in the sort of similarity in all of the hybrid flows, that code is always there, and then the rest of the stuff is what does your front end want. So the token and ID token will allow on this green line, the second response that goes through the browser and the fragment, to obtain the ID token, I, and the access token, A. And it will send the code to its backend, and the backend will then redeem that and get access token prime, A prime, and it will get ID token, I prime. So again, could be different. So another maybe stepping back before we look at this is OAuth defines a bunch of flows. OpenID Connect defines more, and some of those have variants, like this hybrid flow. Should we look at that real quick? And another sort of macro point is that we can build lots of different kinds of apps with this. We have one standard or framework of standards to build all sorts of apps and to solve all sorts of different security use cases. So I'm already logged in here, but what I'm going to do is I'm going to do this code plus ID token response type, the third one we talked about. No, this one we talked about. No, this one we talked about. Code for the back end, token for the front end, ID token for the front end. I'm just going to restart the flow, and I'm already logged in, so my server remembers that I'm authenticated. And now this is interesting. Maybe I'll zoom out a little bit, because there's a bunch of tokens printed on this page now. So we have a front-end ID token, the one that came on the front channel. I think it's in the was in the fragment, but we did some redirects, so we lost it. But the front-end ID token, I was saying, could be different from the back-end one. So in this front-end one, what we do here is the user got masked. So maybe the front-end JavaScript should only see the beginning of the username and the last part of the username. Not sure if this makes sense. It's kind of contrived, but. And then we also have a back-end ID token where the subject is not masked. So the stuff that stays on the server could include personally identifiable information, whereas the JavaScript that's not within our network is not obtaining that PII. And I also get a front-end access token and a back-end access token and a refresh token that is only available to the back-end. So now I can call the APIs. I haven't tested this yet. No, it's not working. I should have tested it before the demo. I think it's maybe because my API is not running. Yeah, it's not running. Let me just start it. Hopefully that's it. Yeah. Okay, so I called with the back-end one, and I could see that the user was John Doe. But so that I don't accidentally leak data, I'll try to call the same API with the front-end access token that was sent on the front channel fragment. And here, the API can only see the masked part. So again, not sure that it makes sense, but it shows the point that I can do different things in different tokens. So you might want to do things differently in your scenario, but at least now you know that this sort of thing is possible. This is also interesting. I'll revoke the refresh token. There's another related spec for OAuth to be able to revoke tokens, but I still have my front-end token, so I can continue to call that. And also interesting, what I did in my configuration of my OAuth server is I said the front-end token should have no scopes, whereas the back-end's token should have at least OpenID Connect. So I'm sort of limiting the scope of access and also masking the data. So the front end, when it tries to call that API, if the API uses scopes as input for authorization decisions, it would arrive at a different one when it sees the scope is nothing, whereas when I use the back-end one, it can see that the scope is more. Does that make sense? Okay. So talked about a lot of different things. Talked about OAuth, the different actors, requesting tokens, how to use it, what to use it for. Use it for delegation, not for authentication or authorization. We also talked about different ways of passing tokens by reference, by value. We talked about how you could use any type of token. JOT tokens were one that we drilled into, but we could use Seaboard Web tokens. We could use SiteMinder tokens. We can do whatever. We have all these different types of tokens, and we can validate them. We can use metadata to create very dynamic environments. And there's much, much more to say. If you really want to drill into this, 1, 2, 3, fourth bullet there, I'll be giving an advanced workshop at the Nordic APIs Platform Summit in October, and my colleagues will be giving more of a starter workshop. So if you want to drill into either of those levels, you can come up to Stockholm. We'd love to have you. And in the meantime, there's a bunch of tutorials on Curity.support and also Curity.io. There's other videos and things that you can watch, code samples to help you to build that. You can find the Python application I looked through by cloning that and tweaking that. And you can always download Curity from our website and start playing with it and trying it out. And if you go to our booth, which is out this door to the right, you can also register to win a Nintendo Switch and take home that to play with when you're not playing with tokens. So thanks, everyone, for coming and listening. I hope that you got a lot out of this session. I'll take any questions if you have some. All right. Thanks so much.